What else?
What else? Oh, I had a question about number 70.
70, okay?
Yes, he did.
70 is pretty self-explanatory.
No, like I'm just wondering how you got that 9.6 and I got 10.
Inverse sine of 3 1/3 divided by 20.
Yeah, I got 10.1.
Did you?
So first I divided 3.5 by 20.
It's not 3.5.
3 and
I
a
thought
half.
it was 3.5 as well.
Oh,
It's 3 and 1/3.
What?
I thought it was 3.5.
No.
3 1/3.
I thought that
Oh.
20 was
Well, I was
the
closer.
3
length
1/3.
was the
It was a
length,
thought
not
determined.
hypotenuse. So I didn't do it again.
At least we tried.
So does that make, okay, done with that one then? Anything else? 30, 32, 30, 20?
Yeah, sure.
Yeah, I just left those as they were.
Easily done in your brain.
I see 30 of them before.
28. The cosine of 3 pi over 2. Well, first you gotta just go like this. Where's 3 pi over 2?
270.
Right here. You gotta like, I should have a quiz, a unit circle quiz. Memorize it. Just draw it.
I just used
What, like just the 4 points?
Just no, all like 3,
Oh,
4,
no.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
That's a different kind of cool right there.
It's easy. It's so easy.
Yeah.
And that's an adder.
It repeats.
Yeah.
And it, like,
It
there's
just
patterns.
has the angular.
You just have to learn, like,
Which one's
I just-
the first 3?
I actually just memorized it at lunch. I was like, oh, I can't remember what order it goes in. And I'm like, oh, it goes a half, root 2 over 2, and root 3 over 2 for the y values. And just off that, I can fill in the rest.
That's different. You dream about math. This is just a class for me.
I do actually dream about math. But anyway, so 3 pi over 2 is right there, right?
Yeah.
So the cosine of that, Talia,
Is 0.
is the x-coordinate of that point, which is 0.
I got that one.
Okay, then for 30, you just do the same. Secant of that same point, well, the secant is 1 over the cosine.
Oh, I got it. Okay, I got it.
So 1 divided by 0 is none defined. So yeah, you had to change it. Tangent of pi. Pi is right here. Tangent is sine over cosine.
It's just 0.
Sine of that point is 0. The cosine is -1. 0 over -1 is 0. The cosecant of that point would be 1 over the sine, which the sine is 0 because the y-coordinate is 0, so it's 1 over 0, so it's undefined.
Impossible.
I hope this is on the test Friday.
You hope? Don't you make the test?
No. I have a test. Like, I have to
Oh.
I was like,
I have to. I won't be here Friday. I will be I'll be done by this time. Friday morning.
You're not going to come back?
Friday morning. No, it's okay.
Oh. Just chill over there.
So.
Go to Jimmy John's, get a nice sandwich. You know what I'm talking about?
You know, last time I just went to Spokane last week and I went to Jimmy John's.
Sweet.
My wife and I actually split a sandwich because I wasn't that hungry, but I did
Oh.
something. We did something before I drove home.
Yeah, no, I always feel like getting a full sandwich, and then I get about halfway through, I'm like, this is a bad choice.
Okay, let's graph these suckers.
No.
It's great. You're gonna love it. It's gonna be your favorite kind of graph.
Yes.
I don't graph well.
Graphs.
Roller coaster time. Roller coaster time.
Why are you trying to
Except for tangents. Except for tangents. Yeah, that's a roller coaster. Like Rainbow Road.
If that was a roller coaster, that would be scary.
Yeah.
That'd be
For
death.
your stomach?
Yeah.
Like aftershock.
Cosine starts tall, dips low. Sine is this one. Wait, no, sine.
We're just gonna do Sine, cosine.
Cosine starts and it goes down.
I think just sine and cosine today.
Well, like,
Sweet.
sine, it goes like that.
And then tomorrow we'll do tangent
That's cosine. but-
and all of the
No, oh, sine starts.
All the
cosecant,
cosecant.
secant, and cotangent.
Second.
So graphs.
Did I say it?
Very muy fácil. Let's just graph first, just start it off with y equals the sine of x. What do you suppose the domain of that is?
Sine of x. All real
All
numbers.
numbers. You can plug in anything you want for x, and do the sine of it, and get an answer for y. Ooh, what do you think the range is?
And
Non-existent?
Non-existent.
Why is?
Then there'd be nothing.
Exactly.
Something.
Now.
Well, look at this.
that's also all real numbers, isn't it?
No.
Well, because if it's equal to x, and x is all real numbers.
What is, okay, what is the sine of 0? Let's just start there. Let's just start plugging in numbers and getting points. The sine of 0 is 0. It's the y coordinate, right?
Yeah.
So, boom, starts at 0, 0. It goes -2.
Oh, yeah.
We're going to go by, we're going to scale our axes here. Let's go by pi. We'll go by pi over 2's. So
Pi
there's,
over 2, so full circles.
there's pi. And there's a reason I'm not going 1, 2, 3, 4, 5, 6, 7, 8. Because then it gets confusing, yeah. It's way easier to scale your axes by irrational numbers. What's the sine of pi over 2?
Oh, hold on, that's the y coordinate. 0. Oh, 1. 2 pi, I was thinking 2 pi.
1. Sine of pi over 2 is 1. What's the sine of pi?
Oh, pi. 0.
0. What's the sine of 3 pi over 2? Negative 1.
1, and then.
What's the sine of 2 pi?
Hold on. I'm still writing the other stuff. 0.
0. And then if I kept going, like after 2 pi would be
It would just
5 pi over 2. What's going to happen?
it would go back to 1.
It's just going to keep repeating.
Oh, so
You
there
just
is
keep
a
going.
difference.
Yeah, so all it does is it goes.
So it's between 1 and -1. Well, like including those points.
Oops, I shouldn't have curved it like that. It just keeps doing that. It keeps repeating forever and ever, ever, always. That's just one called period.
Oh, because it repeats and that's
It's a
like
cycle that repeats itself, except instead of every 28 days, it's 2 pi.
Yep, you eat 2
a
pies.
solid one.
That's what period means. Is there a period? Like it'll say, what is the period of this one? Because we could change the period by throwing some numbers in here and make the period, make it repeat itself faster, which would squish it together.
Okay.
Make it repeat
So
itself.
long.
You can shift it up and down.
You can shift it up and down.
So much fun.
We could stretch it, make the hills taller or shorter. We can do all of those things. So here's well, want to see cosine? It's very similar. You just kind of do the same thing. The cosine of 0 is 1. cosine of pi, I'm just kind of skipping, is negative 1. Cosine of 2 pi is 1. These are zeros. So it's the same, it's just kind of. And it repeats over and over and over. I'm not going to draw. It's just a wave that repeats over and over and over. Do you see the difference between cosine and sine?
Sine starts at 1.
Sine starts at 0, cosine starts at 1.
Oh, because, no,
I don't
No.
understand.
never mind.
What?
Explain this. It's never explained this. Fun.
So,
I
she
It
just
was
called you
really
boring.
loud.
So when it's pi over 2, oh, so it's just the x coordinate. It's like the same thing, but x coordinate instead. Right?
not feeling cheers.
Well, then how does it, I'm just curious how it starts at 1.
What's the cosine of 0?
No, I'm writing a calendar on the hill here, right?
Oh.
Sure.
This words.
Wait.
Same thing kind of happened.
Is that basically
It's
the,
just
the
like
first
color.
point? Like that first thing right there?
Legit.
Yeah,
Oh,
and at first it's
I was
like-
thinking
The
2
rest
pi.
of me fell.
Okay.
I don't know if you first did.
Cosine of 2 pi is also 1.
I-
Well,
she's
alright, now I
like,
see it. Now I
I'm
see it.
pretty sure.
And guess what the cosine of 4 pi is?
0. 1.
Still 1.
One.
6 pi?
Always said that.
1. Say 8 pi?
A few days.
One.
Still 1. It's just going to repeat.
Oh my gosh, the drums.
Okay.
Serious thinkers.
So dumb.
Shifting these.
No. Can't you?
Say we had a in front. We'll just do sine. This works for sine and cosine. Bx minus c plus d.
What does A do?
What does a do?
Isn't that your
Linear.
Amplitude.
Yeah.
You know what amplitude means?
The length.
It's like the height of the hill.
Height of the. Yeah,
Not peak to peak, no.
that's the highest point. That's the highest point, isn't it? Like the vertex.
No, I don't think that. Center line to peak. These all have a center line. Like in this case, it's just right here. It's from here up. So right now, when you have just sine of x, a is 1, the amplitude is 1. It goes up
Oh, okay.
1 and it goes down 1 from the center line. That's amplitude. So the number in front just tells you how tall the hills will be, or how low the valleys will be, depending on if you're at how tall the hills will be or how low the valleys will be as a person. Then we also have the period, and it's not just one of these. To find the period, I guess I could have should have put amplitude is just a. The period is 2 pi divided by b.
I remember this one.
That's how often it repeats itself. In this case, b was just 1, so the period was 2 pi. It repeats every 2 pi. Right? It's on its way up right here. Repeats on its way up right here. If I go 2 more pi, it'll be on its way up right there. Oh,
Whoa. Well, this is a lot.
there's phase shift,
Oh.
which is basically just left and right shift.
We're in the shadow realm of math.
To get that, you do c divided by b.
These equations are going to be given though, right?
No.
No?
Uh-uh. Given right now to you, yes. I'm praying.
Yes. For guidance.
And then there's up and down shift. That's an easy one, Gillen. What do you think that is?
D.
It's just D.
Sweet.
Okay.
So wait, what's A and B? Or no, what's C and D supposed to be? Like the number.
They're numbers.
Like what number is 12?
Any number you want it to be.
Can I feel it?
So on this same graph, I'm going to draw a different one. Man, I did so many examples before. I think you guys are more advanced though, right? So we can just do like, well, okay.
Why don't you do one that has all of them in it and one person?
All at the same time?
Yeah.
Or do you want to just do like one at a time? Like I was just going to do 2 times the sine of x. What does that look like?
It goes up.
Yeah, it just goes up to 2 and down to -2. It still starts at 0, 0. It's just the hills are taller and the valleys are lower. Still repeats the same amount of time. Just got stretched out a little bit. Yeah, easy? Too easy? One hard one?
No.
Let's throw a number on the inside. I don't like any of these. Ooh! That's nice. Can't do that right now. What's that about? How about like y equals, we'll just make one up here. One half times the cosine of 2x. How is it going to change?
So that
Isaiah just
will
got
change
that
the
one
amplitude. The 1/2 changes the amplitude.
What does that mean?
It starts at 1/2.
Yeah, it starts at half. It's just short, it's just going to be like
It's-
shorter.
But that means it's within, yeah, like that.
That's going to be the highest and lowest is half and -half. Okay, what about that 2x?
2x?
What's the 2 do?
Doesn't it structure it out or something like that?
Something like that.
So you gotta take c and you gotta divide it by b.
We have no c.
So,
So there is no phase shift. It's not shifted left or right.
So it's 0. Stays the same.
So it's not shifted left or right. But look at the period. The period's going to change. Period's 2 pi divided by b. What's the period of this?
So,
2 pi divided by 2.
2 pi divided by 2,
So
which
just
is
pi.
pi. So this is going to repeat faster. So it's going to start going up right here, but it's going to repeat by the time it hits pi. So here's how you can graph it really easily. Just start at like 0. Just pick a point, start. If I plug in 0 for x, I get the cosine of 0, which is?
0.
When someone's watching this, like, wow, Kevin's got every single one that was wrong. Every time I've asked. The cosine of 0 is 1. Times a half would be a half. But watch, it repeats every pi, right? So what's going to be, when I get to pi, what's the value of y going to be? A half. And when I get to 2 pi, what's the value of y going to be? A half. Good. No? Okay, so now we got those. What else is easy? I don't know. Should we plug in pi over 2?
Pi over 2? Okay. That's just pi, isn't it?
If you plug in pi over 2 for x, you
Cosine of pi.
Cosine of 2
Which is
times pi over 2,
Negative
which is the
1.
cosine of pi,
Negative 1.
which is -1, and you got 1. Times a half,
So, negative 1/2.
negative a half. So here it'll be negative a half.
So that means the same thing for the rest.
So what's going to happen at 3 pi over 2?
Negative a half.
Negative a half. And over here, we be a negative a half. So it's going to be something like that. It'd be nice to have some x-intercepts. Where are those going to happen?
In between.
Probably pi over 4, right?
So like
If I do pi over 4 times 2, that's pi over 2, and that's where cosine equals 0, and 0 times everything is 0. So yeah, we'll have pi over over 2's. That's going to repeat here, here, and here.
Doesn't the same thing have to happen at pi,
Same
3
thing.
pi?
Yep, it also happens right here. Now we've got our
Where these tax dollars going to work.
what? Tax dollars.
I think
Yeah.
we're having fun with your sound effects over there.
Huh? I'm learning.
Oh, you don't pay taxes. I don't think you own property.
Nope.
No, but
Or have a
it's,
job.
his taxes if you have a job.
Oh wait, you pay taxes.
Oh, you have a job? That's
Yeah.
right. You do.
I do pay for my education
There you go. You
in a
contribute.
very minimal way.
No, because you probably get it all back at the end of the year.
Oh wait, true. I did when I did my taxes. I got like everything back. But I could have just not done them and like left it.
I just leave mine.
I mean, so that's basically, I mean, we can do more, one here, let's do one more. Let's do a hard one.
That's not hard.
No.
No.
Semi-time consuming, yes. Difficult.
Indeed.
How about y equals -3 times the cosine of 2 pi x plus 4 pi?
Hey, I can't. Yeah. Can you lower it? Y equals 3.
Now we're-
Yeah, that's okay. Okay, I see. Took it up a couple notches. About 1,000.
What
So-
is the amplitude?
It's gonna be between 3 and -3.
The amplitude is 3.
But
It's the absolute value of
But
that.
it's gonna start then, -3. Isn't it?
Oh, oh, yeah. Oh, I didn't do one with shifted up or down.
Wait, well, this one does,
We're
doesn't
gonna
it?
do 2. We're gonna do 2 more. The amplitude is 3, period. How often is it gonna repeat?
Period. 1.
1 is correct.
So look, you got one card.
So, when I scale my axes, what should I go by?
1, 2.
Yeah, we're actually going to go by like 1, 2. We're going to go by integer values instead of values of pi. It's like irrational stuff. It's going to repeat every one. This is going to be really, what it's going to look like. You got an idea? It's going to be like squish. It's going to repeat in that distance. It's going to go up, down, and then back up.
And then the phase shift is 2. What does that mean?
That means if you graph the original one, it'd be shifted to the left too.
To the left? Why not to the right?
Or to the right.
Why?
It doesn't matter. It's like the same.
It doesn't matter?
Because these things repeat infinitely, left and right, so
Okay.
whether you're shifted. Well,
But like,
no, if you like. Okay, I guess that's.
ju-
Technically, it's incorrect. 'Cause the numbers. If you shift it left 2, that is different than shifting to the right.
just to keep it simpler, then like, yeah, to the right. In this case,
It's phase shifting.
yeah.
It's c divided by b, right? 4 pi divided by 2 pi. It's 2. It is positive 2, so it'd be the right 2. That really doesn't help us. The way I do this is plug in some points. What would old Stanberry tell you? Plug in points. This is all about plugging in points. Like, this stuff will help you do it faster. Phase shift doesn't really help you do it faster. Yeah, plug in points. So, what do you like to plug in first? 0? I like 0.
0.
That's 0.
Alright,
So it's
cosine of 4 pi is 0.
Cosine of 4 pi is
1.
1. It is 1. Alright, so that's 2 times around the circle, which is still just 1. So 1 times -3, it's going to start down here in -3. Woo! So I guess what else we know?
About what?
We got lots of points.
So every 1 there's a...
Every
It's a
every time you go over 1, it's still going to be a -3. Boom, 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 down. I'm going to do Which do you think we should plug in next?
2 pi? Or what, no, pi over 2.
Pi over 2? Where is that at here? Pi
I
over
mean,
2, that's 3.14 divided by 2. It's like 1.57.
1 half. 1 half.
Yeah, let's plug in 1/2. Remember, we went by ones. So let's plug in 1/2 for x. 1/2 times 2 pi is
Pi.
pi. Pi plus 4 pi is
5 pi.
5 pi. The cosine of 5 pi.
0.
Easy, right? 2, 4, 5.
No. Oh.
It's -1. Right?
No, because every 2 pi. Oh, true. Never mind.
2, 4, 5. Cosine.
I was thinking of it in 180.
So we got -1 times -3. 3. So at every half will be a 3.
And then I'm gonna guess the x-intercepts are at the quarter points.
The x-intercepts will be at the quarters, yes.
Oh, so yeah, there's a lot.
Because yeah, these things are pretty symmetric. You can kind of figure out the rest once you get a few points. And then there it is. It's just going to go
So it's always gonna be like that, like that sort of problem.
What?
So it's always gonna be that sort of problem.
that sort of problem.
Like I don't know. I don't know. What I
You
said.
know what you mean? Okay.
I was mesmerized.
I'm done.
Cool.
Not really. This stuff gets pretty cool once you start like applying it to system vibrations and systems and stuff. Like if you do.
No, what was it? There was that one game you had us play on the laptops where you tried to move the balls to the
Oh
stars.
yeah.
I was trying to write my name half the time. Didn't work.
Yeah, because your name is not a function. So you'd have
Well, I was
to
trying to use different lines. Like for the G.
Oh yeah, just make it like piecewise.
Uh huh.
Yeah, that would.
I couldn't figure out how to cut off the proper.
Final example.
The restrictions in the name. Yeah.
But it had to be sideways.
Y equals 2 plus 3 times the cosine. Or do you want to do sine? I don't care. Let's do cosine again. It doesn't matter. Did you know you could write two different equations for the same graph, one using sine and one using cosine? You just make the phase shift, like where'd my original ones go? If I just take the cosine graph and shift it over pi over 2, it becomes the sine graph. Okay, if I took this black one right here and just went over pi over 2, it's this one. So if you made the phase shift equal pi over 2, so if you let C be pi and you let B be 2, so if you did the sine of 2x minus pi, you would have cosine. Crazy, huh?
It's wild.
Okay, this one. I want to show you this one just because it's a little different. Amplitude. 3 again. Period.
What? Period.
How about Amy? Amy know the period? Come, Amy. 2 pi divided by b. 2 pi divided by the number in front of the x.
Divided by 2?
2 pi divided by 2. Pi. Okay. So this will help you scale your axes now. Probably should go by pi. Good enough. The center line on this one is going to be different. It's not going to go up to 3 and down to -3. Do you know why? It's shifted up 2. I wrote it in front, but it could be +2 at the back, same thing. So it's going to be shifted up to. So that's like where your center line will be. You don't have to draw this, I just like to draw it because that tells me where it's gonna like reflect about. So really, what's the highest point gonna be? 5, and the lowest will be
2?
no.
No? Oh, wait.
That's where the center line will be, and if the amplitude's 3, it's gonna go
Negative.
up 3 from there and down 3 from there.
-1.
-1 will be the lowest. Lowest points. Now you just plug some crap in, repeat it every pi. So we plug in 0, cosine is 0, 1, times 3 is 3, plus 2 is 5. That's going to repeat every pi. Probably almost draw it just from there. The lowest point will be halfway in between these. Just using tricks now. X-intercepts, pain in the butt here. I'm not even going to worry about it. They'll be weird numbers.
They just exist.
Let's get B's points along this line. They'll be in between. They'll be like pi over 4s. That's where it'll hit the center line. So should just do tangent right now.
What?
Huh? Okay, fine. No,
Yeah. I don't know, my brain's already overloaded right now.
Page 410, number 2 through 10, even. 16 through 18, 43, 50, 57, 69 through 76. That seems like a lot.
It does.
You're okay,
I agree. Those are the, you want to do evens, right, between,
If there's tangent, you want us to skip that one?
There's tangent? There's no
Is there?
tangent.
I don't know.
Nope, no tangent. This section is just graphs of sine and cosine. Oh, like these ones, you're just finding the period and the amplitude. So that should take like 4 minutes. And 16 through 18, you just describe it, like what happens. Does it get shifted? Does it get stretched out? Period, shorter. These ones, the only ones you actually have to graph are these 3. That's not so bad, is it?